All right, guys, we're going to go over test unit 2 review. Our test is coming up on Friday. You'll notice the layout is a little bit different here. That way I have some space to write in, so you may want a separate sheet of paper for some of your work. But as always, guys, feel free to pause if I'm going too fast. If you just want to try the problem on your own and then check the answer, you can do that as well. All right, so the first problem we're doing is a greatest integer function problem. Remember that whatever is inside this bracket gets rounded down to the nearest integer. The easiest way I can show you how to do this problem if you're still struggling is make a table of values and just pick the most basic points, 1, 2, and 3, and we're going to substitute those in for x. Or we can do this in the calculator. If you need help putting in the calculator, let me know so I can help you out with that. But if we do it the old-fashioned way and we substitute x, or if we substitute 1 in for x, so there's the work for when we substitute 1 in for x here off to the side. Pretty basic arithmetic here. And we just want to make sure we put -4 in for y. And if we picked 1.1 for x, or 1.2, or all the way up to 1.9 for x, we would get the same result for y. So I'm going to go ahead and graph just that point, the point 1, -4. Oh, that's right here. So there's our next point. When x is 2 and we substitute that in, we get -2 for y. And again, we could check this in our table of values in the calculator and get these points just as easily. All right, so there's our 3 points, 1, -4, 2, -2, and 3, 0. You should notice one thing from each successive point. We are going up 2 and over 1. We're going up 2 and over 1. And that's because of our amplitude of this problem is 2. So this is very similar to the absolute value functions. And then you also notice this point at the point 3, 0. That should look familiar, that number -3. Just like absolute value functions, the vertex would be the opposite of that number, and then whatever number is on the outside. So it's very similar with these greatest integer functions, how we're shifting this graph. The only difference is we have to include all the decimals. So all the decimals that are included that we've talked about. So all the numbers right here between the closed circle and the open circle also will transform to -4. And that pattern you should just see just repeats itself each and every time, only when we're graphing these greatest integer functions. And we could continue to go up 2 over 1 to find the next point, or we could do the opposite. We could go down to left 1 to find the next point. So that's a greatest integer function. If you're having trouble with those, let me know and I can probably show you a little bit better on how to do this problem if you're still struggling. If I remember correctly, there are 3 of these on our test on Friday. All right, number 2 is a piecewise function. So we've got 3 separate pieces to this graph. Remember, the first thing we did the other day was figure out where our border lines are going to go. So our border lines should be at x equals -2 and at x equals 1. So we've got 2 border lines that we can go ahead and draw in now. So we've got the border lines drawn now. Now we want to graph the first line, and the first line is the line y equals 4, but we only want the piece of that line where x is less than -2. So that means for our t-chart for this problem, we only want x values at -2 and smaller. So that means we want to pick values that are less than -2, such as -2, -3, and -4. We've looked at this line a lot. For the line y equals 4, it doesn't matter what x is, y is always equal to 4. And then don't forget, this is going to be an open dot at this first point, -2, 4, and it's an open dot because of this symbol right there. If it's just less than or just greater than, it's an open dot. If it's less than or equal to or greater than or equal to, it's a solid dot. So we're going to graph those 3 points. So that should be our first line graph. That's the line y equals 4 only when x is less than -2. So we're ready to graph the second line. So I said second line, but y equals x squared. If you put that in the graphing calculator, you should see pretty quick the graph is not a line, it's a parabola. It's a U-shaped graph. So this graph's going to look a little bit different, but we're still going to graph it the same way. Make a table of values, and the values for x we want to pick here are the values in between -2 and +1. So we want to pick all those integers between -2 and +1. So we're going to evaluate the function y equals x squared when x equals -2, -1, 0, +1. So again, you could have found these points by putting in the calculator, and make sure you're actually coming up with the answers yourself too. You want to make sure you're practicing this because this is very similar to the actual test, and you will have some x squareds on the test on Friday. So now we've got all the points we need to have for this function. We're going to go ahead and graph them, remembering that the graph should have this basic shape. The one other thing we need to make sure we remember to do is whether it's open or closed dots. Back up here in the original problem, it said -2 is less than or equal to x. The less than or equal to means it's a solid dot. And it also says x is less than or equal to 1. So it means we have a solid dot on both ends for this one. So that's what the middle portion of this piecewise function should look like. Should look like a little bit of a curve. And remember, you don't have to use separate colors here. But since those points intersected right there, that's why it's now filled in. Because we had an open circle and a closed circle. The closed circle always wins that battle. So now we're ready to graph the last line of this function. All right, so for this last one, y equals -2x plus 3, we only want the piece that is greater than 1. So we're going to pick values starting at 1, and then we're going to pick values that are greater than 1. So 1, 2, 3 are my choices. I know I'm going to have an open dot here, and we're just going to substitute 1, 2, and 3 in for x. So you can make sure you can come up with these points yourself, but we're going to go ahead and graph those points, and the piecewise function will be finished. So there's your complete answer on number 2. So this is a problem I encourage you to try on your own first before you see the answer. But remember, the h is the x coordinate of the vertex, the k is the y coordinate of the vertex. So there's the vertex. The vertex should be at the point 1, 2. Or we just take the opposite of this number right here. And that's where we got a vertex of 1, 2. And I think mostly what we did in class was we found 2 other points in the calculator, and you can do it that way. But a lot of you are starting to use that amplitude, which essentially acts as the slope. So the amplitude for this function is 2/3. And it's also a negative number, so that means this graph should be facing down, should be upside down. So to get 2 other points on this graph, you can use the calculator, or we can just count down to right 3 and down to left 3. If you use the calculator, you may find 2 different points than I have found, but your graph should have the same basic shape. It should be just as wide as mine, and it should be facing down. All right, number 4, make sure we change number 4 to look like this. So it's not a 2x inside the greatest integer function brackets, it's just an x. And again, I would pick the same, basically 3 points for x. substitute them in, or look in your calculator to get these values, and then check back and see if you get the same thing. So these should be your points you came up with. Remember, this graph is not a line, it's a step function, it's a greatest integer function. So all of our graphs here should include all of those decimals that are also rounding down. So our step function should look like this. And again, there are shortcuts. A lot of you are using the shortcuts. This -3 just shifted the original graph, which I forgot to draw in. Just shifted that original graph down 3 units. The slope, or I guess the amplitude, was -1. So that's why we are going down 1, right 1, down 1, right 1 to get each successive step. So that's why our steps are going down from left to right. Usually they're going up from left to right. So that's our answer to number 4. I would encourage you on the test, in case you think you will forget. Less than or greater than gives you an open dot. It's got the or equal to sign. It's a closed dot. Think you'll forget that? Put that on your test as soon as you get it on Friday. But we're going to graph both of these functions, same way we've been doing the others. It's a piecewise function. We want values for x that are less than or equal to 2. So I'm going to start at 2. I'm going to pick numbers that are less than 2. So 0. And substitute those in to find y. One thing we didn't do at the beginning of the problem, you don't have to do this, but it's helpful for some, is draw our borderline. We should only have one borderline, and the borderline is at x equals 2. So here's the first piece of that graph. And remember, this is a solid dot at x equals 2 because of the or equal to sign. So now let's graph the other piece. All right, so for this function, x squared plus 1, which again, when we graph it, should be a U-shaped, a parabola-shaped graph. We're going to have an open dot at x equals 2 at the dividing line. And then we picked values for x that were greater than 2. So this one was a little difficult to graph because 310 went way off our graph. 417 is not even really possible at all to graph here. But the key thing is you have to know for this problem, since it's an x squared, it's going to be a curve. It's not going to be a straight line, so you would get points taken off for that if you drew a straight line. Check, if you don't know, put it in the calculator, press the graph button, look at the graph to see whether it's a line or a curve. All right, so I've skipped some steps here. This is really how you should start this problem. The dividing line is at -1. We're going to graph the line y equals 2, and we want values for x that are less than -1. So that's why I've picked -1, -2, -3 for my x's. For this particular problem, y is always going to equal 2. So this one's pretty easy to graph, should be a horizontal line. Make sure you have an open dot at the point -1, 2, and not a closed dot. All right, then for the other line, y equals -2/3 x. This one I would encourage you to avoid fractions, especially if you're using the graphing calculator to get your table of values. Try to find points where you avoid fractions, but we still want to pick values for x that are greater than or equal to -1. So that's why I've got -1, I've got 0, I've got +3. We're going to substitute those in for x. And remember, there is a closed dot at -1, where x is -1. So we can't avoid all of the fractions because this line intersects the borderline at a decimal point at -1 2/3 or -1.67. But that's ultimately what that line should look like. Again, greatest integer function. Stick with easy values. Remember that this graph should look like a step function. It's not a line, it's steps. So substitute 0 for x, 1 for x, 2 for x. Should get those points. And again, you should see a common slope in this problem. We're just going up 3 over 1, up 3 over 1. That's our amplitude. It's a positive 3, so that's why we're going up from left to right. And notice this very first function started down 1 unit from the origin, and that's because of that -1 right there. All right, so the next one is an absolute value problem. First, identify the vertex. The vertex for this should be the point 2, 0, because there's no number on the outside, so that's just assumed a +0 out there. So that's our vertex, and we can either use the calculator to calculate 2 points, or it's much easier, use the amplitude. Recognize that it's a negative, our number out front, so this is going to be an upside down V. And to find additional points, we can just go down 1, right 3, or down 1, left 3. It is possible that, again, you have different points than I do, but again, your graph should still take the same basic shape as mine. Should be facing down and should be pretty wide. All right, on number 9, they give us some information about an absolute value equation. We need to first come up with the equation and then graph it. So they give us the amplitude as 2/3. It's not reflected about the x-axis, so that means it's a positive 2/3. The x-coordinate of the vertex is -1. A lot of you can probably skip this step, but the formula has a minus in it. And then additionally, h is -1, and then +2. And of course, if you didn't already see it, that double negative turns to a positive. So our equation is y equals 2/3 times the absolute value of x plus 1 plus 2. And now we can graph that function. We already know what the vertex is. The vertex is the point -1, 2. This should be a V-shaped graph. Again, you can use the table of values in the calculator, or you can just use the amplitude of up 2 over 3 to find 2 additional points. So up 2 over 3 would be there, or up 2 the other way, 3 would be right there. So that is what your graph should look like on number 9. Again, please pause if I'm moving too fast so you can get all this jotted down. If you've got further questions, let me know. So given the transformations, write an absolute value equation. It is helpful for some people to draw a graph so they can visually see this. A lot of us are visual learners. So this is saying the graph has been shifted 2 units left from the origin. So we start right in the middle. We're going to go 2 units to the left, and we're going to go 7 units down. So that's that point right there. That is going to be the vertex for this particular graph. And that is the point -2, -7. So that's my H and that's my K. I'm just going to substitute those in to the absolute value equation form. They don't give us the amplitude, so it's an assumed 1. If they don't give us the amplitude, so the equation for this problem should be y equals the absolute value of x plus 2 minus 7. I encourage you, if you haven't already, try number 11 before I go over it. So the shift, it doesn't tell us anything about the horizontal shift, but it does tell us It's been shifted 3/8 units up. So it's not even been shifted a full unit up. It's just been shifted a little bit less than half. So that's where our vertex sits right there. And that's the point 0, 3/8. So that's my H, and that's my K. They tell us the amplitude is 5. And they also tell us it's being reflected across the x-axis. So if something's reflected across the x-axis, that's what it originally looks like. If it's reflected across the x-axis, it's just going to be facing the other way. It's going to be facing down. Of course, we know if it's facing down, the number out front is negative. We can tidy this one up a little bit. X minus 0. Anything minus 0 is just itself. So this would be the answer, the correct answer for number 11. All right, the last set of problems where we're working backwards, we're given a graph, we need to write an equation. So first you need to identify what kind of equation we're going to have here. You should notice this is an absolute value graph. So this is an absolute value equation we're looking for. So the vertex is the point, well, let's see. The vertex is the point -1, -2. So that's my H, and that's my K. It's facing up, so we're not going to have to do anything with negative signs here. The only other thing we need to do is we need to be able to find the amplitude. So the amplitude, remember we need to find one other point on this graph. So it looks like we've got a point right here. The amplitude is similar to the slope, or we could pick this point right here. Either way, we want to count up and over, just like rise over run. So we're going up 1, over 1, 2, 3, 4. So the amplitude is 1 over 4. So we know H, we know K, we know A. Substitute those into this form right over here for our answer. So y equals 1/4 x minus -1, which of course has become a +1 minus 2. All right, and then number 14, the piecewise function we've got here. First thing we should notice, the boundary line is at x equals 0. So we're going to have, and don't worry about this note on the restricted domain. I don't think that's on your papers. So the boundary line is at 0. So let's first look at this line right here. We're going to concentrate on calculating the equation for that line. We only want the equation of that line when it's less than 0. Notice it's the arrow to the left of the y-axis. So we only want the equation of that line that's x is less than 0. It's an open dot, so that's why it's less than. So the equation of that line is in slope-intercept form. This is where it crosses, my line crosses the y-axis. That's what B stands for. So B is where the line crosses the y-axis, and M is the slope, which of course is just the rise over the run of the graph. Should be pretty obvious where it crosses the y-axis. It crosses the y-axis right here at -2. So that's what's going to go there. So all we need to come up with is the slope of this line. So pick any 2 points on that line. We definitely, of course, have a point right there. And the only other point I see where it definitely crosses, looks like, is right here. So from these 2 points, the rise over run, we're going down 1, 2, 3, 4, 5, and we're going over 1, 2. So the slope of this line is -5/2. Again, if you need further instruction, these are probably, for some of you, going to be the most challenging problems. Let me know before you leave today. So now, secondly, we're going to graph this line. And this one's a little tricky. We want the values for x that are in between 0, and it looks like it stops at x equals 3. So we only want the piece of this line that is in between 0 and 3. So it's all the values where x is greater than or equal to 0, and also the values for x that are less than 3. So we need to come up with the equation of that line the same way we came up with the equation of the other line. We need to find where it crosses the y-axis, which again should be pretty easy, because where it crosses the y-axis, we can actually see it's at the point 0, 1. So the y-intercept is 1. And then we just need to find the slope. We need to find the rise over the run, which again should not be too difficult because we've got 2 points here and here. We're just going up 1 over 3. The rise over run is 1 over 3. Probably the hardest part I can imagine for some of you in this problem may be coming up with this part right here. So let me know if you're having trouble with that. But this is our complete answer. It wanted us to write equations for the graph provided. So coming up on the end, number 16 is an absolute value function. You've got to know standard form for these in order to do well on this portion of the test. Again, this review is very similar to what you're going to see on Friday. So we can identify the vertex. The vertex is the point 1, -2. So that's my h, that's my k. This graph is facing up, so that means that number out front is going to stay positive. And then we just need to find the amplitude, which is similar to finding the slope. So we can just do rise over run from our vertex to either one of these points. So the rise over run, we go up 1, 2, 3, and over 1. So that makes our amplitude 3 over 1, or really just 3. So we know what A is, we know what H is, and we also know what K is. I encourage you to try number 17 before I go over the problem. If you want to go ahead and hit pause before I start that one, that'd be a good thing to do, good practice. All right, so our final problem we'll do together here. There's, of course, an additional sheet with just 3 other practice problems to do on your own. But we need to find the vertex, just like the last one. The vertex is the point, what is that, 1, 3? 1, +3, not -3. So that's our H, that's our K. This graph is facing down, so that means the leading coefficient in this problem is going to be a negative. We just need to figure out what the exact amplitude is by picking one other point. And this one's pretty easy to find. Just from the vertex to one other point, we're going down 1, right 1. So that means our amplitude is -1 over 1. Which of course just simplifies to -1. So you can either put the negative here. I guess I shouldn't have probably done that. You can either put the negative here, or you can put the negative in at the beginning. Either way, make sure the leading coefficient is negative, since this graph is facing down. And that should be your answer. We don't really need the -1. We can just put a negative out in front. So please study this. I want everybody to do well on this test. The scores, I think, for some of you were a little bit lower than what you wanted on the first test. But again, this review, very similar to our Friday test. Let me know if you got any questions rest of the period. I'm also after school tomorrow on Thursday. Good luck.